Let's close this section on land surface modeling with proceeding on the actual predictability and prediction. So that is implied here. So this is done specifically for food security issues over Africa. You hear the bird going loudly there, which is nice. Predictability and prediction. We can look at the variation of land impact on atmosphere across various climate regimes, including how the necessary ingredients of land atmosphere coupling vary. So coupling typically means predictability, because that means each system depends on the other one, and there are feedbacks which give you timescales and predictable statistical features like coherence of rainfall. We looked at and we said coherence of rainfall is much larger spatially on the ocean compared to land, and there was seasonal variability and so on, and land in general has smaller decorrelation scales for almost everything. But if it is coupled, then it is modulated by the processes happening in the land and atmosphere. Of course, remembering atmosphere has even lower heat capacity than land. You have to be sure who is providing predictability to whom. Okay, so the regions here go from semi-humid mid-latitudes, summer monsoonal subtropics, arid mid-latitudes, humid mid-latitudes, arid subtropics, humid subtropics, high latitudes typically of interest for winter, and high latitudes in summer and mid-latitudes in winter as well. Land atmospheric coupling strengths here, which is essentially how perturbation to one quantity on land will affect the atmosphere, and then atmospheric response will affect the land process back, is what is the coupling strength, how closely they are tied to each other. And so these are, some are high, some are medium, mainly terrestrial leg, medium and low. For example, arid subtropics don't have any memory, there is no soil moisture. Humid tropics, they have very fast acting convective processes that fire up very quickly and reduce overall predictability in general compared to, let's say, mid-latitude synoptic systems, which are 1,000 kilometers large on scale and can linger for 10 days. Humid tropics have very fast systems, and the coupling of land-atmosphere system is very low there as well. And similarly, high-latitude winter and high-latitude summer and mid-latitude winters as well. Just keep that in mind, and you can follow up the references if you are interested why this is high and why this is medium, why this is low, and so on. But intuitively, I hope you're getting a sense. But it is helped here by looking at soil moisture memory. It's moderate here, long in the dry season and short in the wet season. So this determines the feedbacks as well in terms of, for example, persisting droughts, or feeding back to the rain processes in terms of re-evaporation and recycled precipitation and so on. Arid mid-latitude climate, soil moisture memory is long, moderate to short, and so on. So here it's long in high latitude winter because it's frozen, so the land can be covered by snow and protected in terms of heat exchanges. And then when the snow melts, then you have fast exchanges during spring and summer months. Okay, so looking at land impact on the atmosphere, it's high here, especially in major agricultural areas, high in a dry season but not in wet season, medium, and so on and so forth. So go through these processes and see how this works. So to look at how the potential predictability is actually exploited by models or exploitable, we are looking here at sensible heat flux dependence on soil moisture, so that's kind of a coupling strength issue. And here the skill is looked at in terms of ratio of pentad forecast improvement time to soil moisture memory. Okay, so various initial conditions, 1st April, 1st May, 1st June, to look at the seasonal dependence, for example, of the 2-meter air temperature and 2-meter specific humidity here, looking at the coupling strength of the latent heat flux and the 0 to 10 centimeter soil moisture coupling index in watts per meter squared. So do these coupling strength indicate anything in terms of prediction skill that can be exploited over a pentad? Okay, and you can see that there is a huge scatter for each variable and each initial condition, and forecast skill improvement implied here. There is an indication of forecast skill improvement, but the scatter is so large that it's not really that impressive. That's the main message. Okay, scatter distributions of terrestrial coupling indices of sensible heat flux to linkage to soil moisture on the left, and evapotranspiration, which is latent heat flux, linkage to soil moisture here, as a function of the fraction of soil moisture memory duration realized as forecast skill. Okay, on the x-axis here in the coupled forecast system version 2 of NOAA for 2-meter air temperature and specific humidity for ensembles. We remember what ensembles are, with indicated start dates we talked about over all global land points that are ice-free and do not have frozen soil, so no permafrost and so on. Red bars indicate mean values, blue boxes mark median, first quartile and third quartile, which is a typical way they are expressed. Straight lines are linear regressions through the medians and quartiles. Okay, so there is potential predictability from soil moisture memory and based on these coupling strengths, but when you look at the global level forecast skill improvements, it is not that impressive. So potential predictability is not necessarily realized. But the good news here is that the number of pentads where the monthly mean forecast of the indicated variables in 28 years of CFSV2 hindcast, so you go back in time and do the forecast experiments, with realistic land surface initialization for the indicated dates remains significantly better than forecasts with randomized initial states. So when we do initialize forecasts, you always want to know if initialization actually has an impact. This goes back to our earlier discussion on how weather forecast is a chaotic system. So if you initialized the system and did integration after a few days, depending on the latitude and the season, the forecast becomes chaotic, and the skills have improved over time. They have extended from 3 days to 5 days to 7, maybe even 10 days, so short to medium range. And we were looking for S2S predictability from various processes and various statistical properties like coherence of rainfall distribution over land, for example. Here we are looking at the value of initializing land surface. Remember, climate forecasts, seasonal forecasts are typically done by initializing the ocean, because ocean is a boundary forcing that gives us the predictability of the second kind. Even if weather is chaotic after a few days, we still have predictability at seasonal to intriennial timescales, like El Nino, for example, and El Nino teleconnections to monsoon, etc. Then does land initialization also offer some forecasts at any time scales? So long story short, you can see we are looking at pentads here, and the colors indicate the places where predictability or the forecast skill is extended into those pentads because of land initialization compared to where there was no initialization. Okay, so there are definitely regions all across the globe for both 2-meter air temperature and specific humidity for various initializations, 1st April, 1st May and 1st June. And this is a positive news because the data availability is increasing, assimilation schemes are improving, land models are getting more sophisticated. So land surface model initializations actually extend predictability of quantities like air temperature and specific humidity, and presumably that extends to other predictions of precipitation and so on as well. Okay, so that's good news that land initialization does work. So that idea is now carried into adding more details to the land vegetation soil interactions, carbon cycles, ecosystem dynamics, dynamic vegetations, ice sheet models on land, representations of carbon above and below ground, and so on and so forth, so that longer term climate predictions and projections, for example decadal predictions and multi-decadal projections, can be made. So land surface processes are now definitely considered important for not only S2S timescales but for multi-year timescales, which are now referred to as societally relevant timescales, and decadal timescales, which are for many sectors decision horizons, and projections out to 2100, which are obviously being reported by IPCC every 7 years, with all their debates about where the uncertainty comes from in the shorter term of decades, which is mostly from models uncertainty, and longer time scales where the uncertainties come from scenario uncertainties. If you don't understand what that means, don't worry about it, but you get the idea that land surface model model initializations. Validation is still an issue. There is severe shortage of data. Initialization is being done, but obviously more data will also help initialization. And skill assessment is also helped by data. So there are more and more satellite missions and programs like GVEX, Global Energy and Water Cycle Experiment, which collect data across the globe. There are flux towers and so on, which are improving data coverage, data quality, initialization, and parameterization of land surface models as well.